So today's section is 9-8, volumes of prisms and cylinders. I want a quick review at the very beginning what prisms are, what cylinders are, just so we're kind of all on the same page with that. Prisms are going to be things that they have to have, I don't know, I'll write it, you could write it if you wanted to, but they have to have two surfaces that are congruent. I'll just put the little symbol for congruent. So two surfaces that are congruent means they're identical, same size, same shape, but they also have to be in parallel surfaces. So a prism is going to be something that, so I just realized my notes look like prison. That's not an O-M. Okay, so it's prisms. Let's fix it. It's like volumes of prisms and cylinders. Okay, volumes of prisms and cylinders. So a prism is going to be two parallel, identical, congruent faces. Cylinders, basically those bases have to be circles. So it's like a can of soup or something like that for a cylinder. And we looked at this equation a day or two ago, so I'm just going to write it again here. We have V equals capital B times H. And the capital B isn't the length, like the base length. It's the base area. Nice. So it's the area of the base. So if that doesn't jump into your brain, you might want to kind of write a little note. So this is the area of the base. So having capital B be the area of the base then allows us to have one equation here, one formula that's going to work for cylinders and prisms and all kinds of different things. Instead of having to have one where the base is a circle, one where the base is a triangle, one where the base is a rectangle, and so on. A comment on the H, I'll come back to the comment on the H. I want to look at example 1. So example 1, I'm just going to say find capital V. We're going to find the volume of this thing here. Now, when I have my little picture, the base is going to be what on my picture here? It's sometimes a little bit confusing. That I kind of want to say, well, the base is what it's sitting on. It's that bottom surface that you can't see. But to use the equation, our base has to be two bases that are parallel to each other and identical. So that bottom edge you can't see has two other sides, like this side here should be identical to it, I think, based on the picture, but they're not parallel. So in other words, what we're really finding is the base of this thing, it's kind of like if you twist it this way, the base has to be my triangle surface down here. So this here, that area is going to be the base. Because I have another, if you could see up here on this end here, I have another triangle, if drawn right, that should be parallel and congruent to that other one. So you have to be a little careful in identifying what the base is of your drawing. We put that back. So I try to draw something like that. I figured I'd have my picture, but if I were you, I just would kind of draw a triangle and kind of extend it off with a couple parallel lines and try to have this edge here be parallel to that front edge. I just draw it like that and then kind of put in the dimensions and so on. So you could put in the height, 90 degree. So draw something like that, throw in some dimensions, your notes will make a little more sense soon. And then I'm going to start with my equations. So I'm going to start with, I have volume equals capital B times the height. Now the height, if my base is this triangle shape here, my height has to always be that distance between my two bases. And that was the thing I almost added before. So you might want to kind of squeeze that in back here, that this H that's the distance between the bases. So I could see where that could be confusing and people might want to put in the height of the triangle. But instead it's like you're finding the area of the base and you're kind of finding out how many of those areas are there in that whole length or height of the object. Okay, so we need the area of the base, the area of that triangle. So I'm going to just start with that, and I'll do that in red like my B in my original equation. So my area of the base, I'm going to write that's the same as the area of the triangle. You could write it that way if you wanted to, but it's 1/2 times base times height. So that's our triangle area equation. And I could say, all right, base and height have to be perpendicular to each other, and my 6 and my 5 1/4 are perpendicular. So that works. So I could put in base is going to be lowercase b, the length of the base. 6 inches times 5.25, or 5¼ inches. If I punch all that in, I end up with 15.75, and that'll be square inches because it's an area. We okay on the area? Which now is really our capital B, if you want to call it that. So we could take my 15.75 and put it right there in our equation. So 15.75. And why not? I'll put in the units, inches squared. Now our height has to be that number there. That's the distance to the other base. So times 38 1/4, or 38.25 inches. So grab a calculator. 50.75 times 38.25 gives us a total volume of 602.4375. Or maybe you'd round it to 602.4 or 602.44. And that'll be inches to what power? Cube. Because it's volume, you know it's going to be units times units times units, or inches cubed. The other way to get it is, well, I have inches squared here, so this is like inches times inches, and I have another times inches here at the end, so inches times inches times inches is inches to the third. So, we okay on example 1? So I kind of covered a couple pitfalls. One more example and then we're done. So example 2, just want to do the same sort of thing but with a cylinder. And so if you want to quick draw a picture like that, you can. And maybe I'll write example 2, find the volume, find V. I'm going to kind of blaze into the problem then. So we could say capital V for volume equals capital B, the area of the base, times the height. Actually, I'll see with the same color scheme as before, capital B in red. So we need to find out what's the area of the base. And the base has to be my 2 circles, because I have a circle there, I have the circle kind of at the bottom. Those two will have the same area as each other, so they're congruent, they're identical, and they're parallel to each other. So then my capital B, my area of my base, is going to be the area of the circle. And area of a circle is pi r squared. Now for that r, the radius of this thing here, 9 inches. So if we know the diameter is 18, the radius will be half of that. So I have my 9 squared times pi. So we end up with 81 times pi. I like just using 81 pi. And taking this thing, all right, this here's my answer. This is my capital B in that first equation. So I'm going to put it in up here as 81 pi. Our book talks about use 3.14 for pi. I just don't see the point in rounding. I'd encourage you to just go this way, and your answer will be a little different than the books, but yours is going to be more precise. It's going to be better. Or if you wanted to, I suppose you could punch it into a calculator and get 81 pi is, where's that in? So 254, so 254.469. So you could take and put that number into this top equation if you wanted to. But now we're going to multiply by the height, and the height now is going to be kind of that distance here between my 2 bases, so it's 9 inches. 9 inches. So now I could, if I were to leave it as that 81 pi, I just do 81 times pi times 9, and I come up with 2,290, so 2,290.22. And my area here in red, I didn't write it in, but that would have been inches squared, or square inches, times another inches gives me my inches cubed. I suppose even if you wanted to, you could take your problem, and this number here, my answer has some rounding in it. You could have done 81 times 9, and then just said, okay, that's 729. So 729 times pi is going to be the exact answer. So that would even be a little bit more accurate. My concern about going with decimals, using a number like this here, is, well, once you take that and put it into your equation, when you multiply by this 9, you just took your rounding and made it 9 times as big. So the amount that you rounded now becomes 9 times bigger. You just get further and further away from the accurate number. So if you can kind of do it the way I showed you, I'd recommend it that way. It'll help you down the road when they expect you to do it that way. Any questions on the section? Cool. There was some confusion in the homework. There's 2 questions that say, find the shaded region. And there's kind of like a larger blue area with a smaller green in there. They mean find the area of the larger blue region, not the green. So that'll help the homework make sense.